All right, how's it going? Go ahead and get started. Doing the warm up here. We have 4 questions. The sub's going to take roll. I'm not able to be here today, but I'm going to record the lesson ahead of time so you have it. So go ahead and come in, get started. The sub's going to take roll. This is the warm up. There's 4 problems here. There's 2 equations. I want you to graph the lines and then 2 equations where actually they're inequalities where I want you to solve for x. So y equals negative 2x plus 5 and y equals negative 3x minus 2. I want you to graph those lines. Remember last week we did the y-intercept, the slope-intercept form. And then also what I want you to do is solve for x with inequalities because today we're going to be blending the two. So we need that for the warm up. So go ahead and get started, and I will cover this in just a little bit. All right, I'm going to go ahead and get started here. I'm going to do the first one, which is y equals negative 2x plus 5. So again, from last week, if you remember, this identifies the slope as negative 2 over 1, which is our rise over our run. And our y-intercept is positive 5. Remember, the formula was y equals mx plus b, where m is the slope, and the y-intercept is the b. All right, so we're going to use this information and graph this. So we start with the y-intercept we know is positive 5. We put a dot. And then the slope is negative 2 over 1. So we're going to go down 2 and over 1. Remember, negative slopes, that negative either stays with the numerator or it goes in the denominator. So you could still go up 2, but then left 1. You still land on the same line, but remember that negative can only go with one of them. So then that line is there. Remember, you can label your x and y axis. Label your x and y axis. Now remember, we talked about last week, this is a really important concept. When we give the equation y equals negative 2x plus 5 and we say to graph it, we're really saying show a picture of what that looks like represented in a picture, where all solutions are represented on a line. So any point you choose on this line, if you plug those x and y values into that equation, y equals negative 2x plus 5, you're going to get a true statement. And we tested that a lot last week. So remember, the origin is an easy one to choose because the x and y values are both 0. So really quick, plug in 0 for y, 0 for x, and verify that that is not a point on which it makes that statement true. So go ahead and do that really quick on your notes. And I'll do it right here in the graph. So again, plug in 0 for y, 0 for x, and prove to me that that doesn't work. All right, let's see if you got the same thing. So 0 is equal to negative 2 times 0 plus 5. Remember, you're justifying to me that this isn't a solution because the origin is not on that line. So negative 2 times 0 is 0. 0 plus 5 is equal to 5. And last time I checked, 0 does not equal 5. Therefore, that is not a solution. All right. Next up, we are going to do y equals negative 3/4 minus 2. Y is equal to negative 3/4 x minus 2. Again, the slope is given in the formula, negative 3/4. Which, remember, another way of writing that is positive 3 over negative 4. It doesn't matter what you put the negative in the numerator denominator, but remember, only put it in one spot. and then the y-intercept is -2. All right, so I'm going to graph that over here. My y-intercept is -2, and my slope is up 3 and left 4, or I can go down 3 and over 4. But if you notice, they're on the same line. So again, all you're doing when a teacher asks you to graph something, you're just showing in a picture of what the solutions look like. Remember, we talked about last week, if you were to find every single x and y value that made y equals -3/4 x minus 2 true, if you were to find every single x and y value that made that true, you would be there forever because there's an infinite number of solutions. So we're just going to do it really quick as a picture to represent that. Now, that is a very important concept to understand today when we get into the inequality piece, because we've been testing to see if that's true or not. So again, let's check the origin. If we graph this correctly, the origin 0, 0 should not make that statement true. If we plug in 0 for x, 0 for y, it should not make that true. So let's do that really quick. 0 is equal to -3/4 x, which is 0 times 0 minus 2. 3/4 times 0 is 0. So 0 equals 0 minus 2. 0 minus 2 is -2. So 0 equals -2. Is that a true statement? No. So we know that that is not true. And that's because the origin is not on the graph. It's not on the line on that graph saying that it's part of the solutions. Okay? That's a very key concept to understand as we transition into these inequalities. And remember, we're building that foundation using what you had from algebra, and we're going to apply that to concepts. These same strategies work in a linear way, and we're going to be able to apply that quadratically when we're talking about circles and ellipses and hyperboles and parabolas. We're going to look at pictures on a graph and find out where those solutions are true. All these base foundations are going to be used there in when we transition from linear to quadratic. All right. So let's go back to the warm up, and we need to solve for x. All right, so we have -2x plus 7 is less than or equal to 11, and I want to solve for x. So remember when we talked that balance scale that we talked about the first couple of days of class, mathematics is all about staying in balance, right? And anytime you have an equal sign in an equation and you add something to that scale to weigh it down, you have to counterbalance it the other side to make it equal. Now, you're going to treat inequalities the same exact way as equations, with one exception. And I'll give you time to think about that from Algebra 1. Your Algebra 1 teacher probably reviewed this with you, so this is a review for a lot of you. But you treat them the same except for one major exception. So think about that for a second. And it has to do if you multiply or divide by a negative number. Hopefully it's starting to come back. In an inequality, if you multiply or divide by a negative number, you're going to switch the sign. So I'll say that again. Equations and inequalities, you treat them the same when you're doing the algebra work, except for one exception. If you multiply or divide by a negative number, you flip the signs. So what do I mean by flip the signs? If you multiply or divide by a negative number, then your less than or equal to translates into greater than or equal to. Or if it is greater than, it translates into less than. So you're just going to flip the inequality around to keep that the same. You do that because you just changed the equation. You added weight to the scale. You have to counterbalance it by flipping the sign. All right, so let's treat this the same exact way. We're going to treat it the same exact way as an equation, except for if we ever multiply or divide by a negative, we're going to flip that sign. That's the only thing we have to keep in the back of our mind. All right, so I'm going to subtract 7 from both sides. That crosses out to 0. So now I have 2x is less than or equal to positive 4. And I need to divide both sides by negative 2. Now here's that rule that I came across. Did I just multiply or divide by a negative? Think about it. I did. I'm dividing by negative 2. So that one rule that I have to keep in mind to keep that scale balanced, I just divided by negative 2. To counterbalance it, I need to flip the inequality. So negative 2 divided by negative 2. X is now greater than or equal to negative 2. So that is your answer for the warm-up for question 3. All right, the next one, 5 minus 3x is greater than or equal to negative 13. All right, again, I'm going to treat it just like an equation, except for if I multiply or divide by a negative, I need to flip the inequality. That's the only thing I need to keep in mind when I'm doing this. So I'm going to subtract both sides by 5. Remember, keep that scale balance. What you do to one side, you have to do the other. So I have negative 3x greater than or equal to negative 18. Okay, I'm going to divide both sides by negative 3. Did I just do the one rule I have to keep in mind? Think about it. I did. If you multiply or divide by a negative number, you have to flip the inequality. So I need to flip this inequality from a greater than or equal to less than or equal to, and I'm going to get positive 6. So y is less than or equal to positive 6. What does that mean as a picture? Any value that you plug in will be less than or equal to 6 will make it a true statement. And you can check that just like we did with the graph. Same exact thing. Now what we're going to do is marry the two. All right, we're going to take inequalities. We're going to take showing pictorial graphs. And we're going to join the two together and see what that looks like. What is it going to do to the graph? If I need to display what all the solutions are in a picture, and I change it from an equation to an inequality, I need to make the picture look different. And I'll show you how to do that as a review. I know you did it in Algebra 1, but this is an important concept that we have to hit home. And we're going to review that right now. All right, so going back to the beginning. Bear with me as I have to do two screens at once or I'm recording this. And I'm getting a cell phone call. All right. So here's our essential question for today. So for those of you in Avid, you need to make sure this is in your notes. If you're not in Avid, it's still a great strategy for every student to use. All right, so essential question for today. How is the graph of a system of linear inequalities related to the solutions of the system of inequalities? Okay? So that is something that we're going to think about and be able to answer by the end of this. All right? How is the graph related? So remember that picture in mind. We need that picture in mind. Okay? All right. So what I need to do is do not do the second one. Let me hide that. There we go. So I'm going to hide that from you. So I only want you to focus on y is greater than or equal to x minus 2. So we're going to treat this just like an equation in terms of graphing, just like we use the point slope form or the slope intercept form to graph these. You could do the same thing with inequalities. You still have a y-intercept, you still have a slope, and you can graph the line. But you need to know when there's inequalities what to do differently. So the slope's still the same, the y-intercept's still going to be the same. So we're going to start by graphing it. So I'm going to go over here to some empty space. And I need to graph y is greater than x minus 2. So y is greater than x minus 2. We're going to treat this the same way as if it read y is equal to x minus 2 in terms of graphing it. So the slope is 1 over 1. The y-intercept is negative 2. And I'm going to graph that the same way that I would if it was an equation. So I'm going to start by going down 2 and put a point. And I'm going to go up 1 over 1. And now normally I would connect those dots with a solid line, because what I was trying to find out in the equation is what exactly would it be equal to. But notice I'm not asking what is it equal to here. I want to know when y is greater than x minus 2. So here's the deal. If it says greater than or equal to, or less than or equal to, these are a solid line. Because they're equal to, the equation part is still in there. But if it is greater than or less than, then those are a dotted line. Now this should be recall for everyone. This shouldn't be new to you. This is done in algebra. So notice I only have a solid line if it's actually equal to, because remember in the equation, that means that that point on that line would make it true. If it doesn't say equal to, then we can't include the line, but everything up to the line. So we have to use a dotted line here. Because our original inequality says greater than. It doesn't say greater than and equal to, it says greater than. So we have a dotted line. Now this is the key concept here. If it's saying I want to know any numbers that work where y is greater than x minus 2, then I'm either going to have solutions above the line that are true or below the line that are true. So we need to find out which ones are which. Now, remember last week I told you anytime you can choose the origin, that's always a good one to do because zeros cancel out a lot of things for a lot of the times when you're doing the mathematics. So we're going to choose the origin here to test. So we're going to choose the origin to test to see if that point is true on this inequality. So over here, we want to know is y greater than x minus 2 when y is 0 and x is 0. So is 0 greater than 0 minus 2, which is negative 2? Is that true? Is 0 bigger than x minus 2? Yes, right? Because any negative number is going to be smaller than 0. Any positive number is going to be greater than 0. So 0 is above negative 2 on the number line. It's greater than. That means that anything that side of the line is true. So what you do is we represent this as a picture by shading that line. And we're going to shade that side that we tested. Now, I'm going to caution you here. If you plugged in 0, 0 and it was not true, guess what side of the line you'd shade? Think about it for a second. Hopefully you said the other side. Because if I chose 0, 0 as a point to test and it wasn't true, that means that side of the line is false. That by default, the other side must be true. And so then any point that I choose over here would be false. But any point I choose on this side would be true. So it's the same concept as an equation, except for a bunch of points lined up on a line. It's really anything that side of the line, up to the line, but not including because it doesn't have the equal sign. All right. So I want you to now do on your own. I want you to do this one. Y is less than or equal to negative x plus 1. You do that on your own. I'll give you some time to do that. I'll give you some pointers. Start with what you know. You know the y-intercept. You know the slope. So draw that line. Then what you need to keep in mind once you have that intercept and the slope, when you go to connect those, you need to know, is it less than or equal to, greater than or equal to, less than, greater than, because you need to know whether it's a solid line or a dotted line. So refer back to your notes and go from there. And I'll give you some time right now to work on that. All right. What I'd like you to do is share with your table partners what you got for the slope and what you got for the y-intercept. You got 30 seconds. Quickly share. Okay, about 10 more seconds. All right, eyes back up here. All right, so the slope, you should have received -1, which we also write -1 over 1. And the y-intercept, you should have got +1. All right, so I start with the y-intercept. I go up 1, and I put a dot because I know that the line is going to cross that point. And then I'm going to go down 1 over 1. I'm going to put another dot. Now remember, this is an inequality, not an equation, so I need to double check. Does it include an equals or it doesn't? And so I get a dotted line. Remember, refer back to your notes. Greater than or equal to, less than or equal to, they get a solid line because they include the line. And then less than and greater than does not include the line, so they get a dotted line. So you should have drew a solid line here because the equals was in the inequality. It said y is less than or equal to, so it includes the line. Now quickly check the origin, the point 0, 0 in the inequality. We need to see if it's true or not because we need to know if the origin side is shaded or if the other side is shaded. So if we have 0 is less than or equal to -0 plus 1. Well, -0 plus 1 is 1. So is 0 less than or equal to 1? Is that a true statement? Think about it for a second. Is 0 less than or equal to 1? Yes, it is. Good. Okay, so what we're going to do is we are going to shade this side of the line because the origin's on that side of the line. Therefore, since that was true, everything on that side must be true. And if you want to double check and choose a point that's out here, like 3, 3, and verify that that's false, you'll see that that's a false statement. And that's why that side does not get shaded. Because as a picture, anything that side of the line would make that inequality a lie. It would be false statement. So we don't shade that. I want to give you some time to graph one on your own. I get the pen instead of the eraser. All right, so graph y is greater than -x plus 2. And I'm going to throw a challenge out there. On the same graph, I want you to also graph y is less than -x minus 2. So I'm giving you two inequalities to graph. I want you to graph them on the same line. Make sure you treat them differently. So if you have different colors, that'd be great. If not, don't worry about it. I'm going to give you some time to work on this, and then we're going to bring this together. This should be a review for you. and it should start connecting once you start doing it. But if not, I'll cover it here in just a second. So I'm gonna give you some time to work on that. Go ahead. All right, so now that you had some time to work on this, what we're going to do is we're going to graph both of those inequalities. We're going to do this one in blue, and we'll do the other one in green. Okay, so we'll do that one in blue, and we'll do this one in green. And let's see what they look like in the picture. All right, so with the blue one, we need to go up 2 and then down 1 over 1. And it is greater than or equal to, so it includes the line. So we don't do a dotted line. I'm going to quickly check the origin. Is 0 greater than or equal to 0 plus 2? That's a false statement. So therefore, the other side must be true. So then I shade the other side of the line. Now let's go to the green one. I'm going to start with -2, and then I'm going to go down 1 over 1. And I need to, oops, it won't let me erase dotted line. I have to make a dotted line. So I have a dotted line because it's less than and not less than or equal to. So it's a dotted line because it's less than and not less than or equal to, which means that the line in the picture does not represent things that will make that true. So you do not include the line, but you need to include everything up to the line. So again, let's test the origin. Is 0 less than -2? Is 0 smaller than -2? No, it's not. So therefore, this side of the line must be shaded. So what does this mean as a picture? So let's break this down a little bit. So these are parallel lines. If you remember that from geometry, algebra, parallel lines. That's where they'll never intersect. And parallel lines have the same slope. Notice that these two equations have the same slope. So they're going to be parallel lines. That means they'll never cross. So I'm going to put 3 dots on there. I'm going to put a red dot. I'm going to put a black dot. I'm going to put a purple dot. I just changed my mind. I'm going to put 4. Let's find another color, orange. So I have 4 colored dots here. So the red dot is true for the green equation. The black dot is not true for either one. Notice it doesn't fall. This black dot here does not fall in an area where it's shaded at all. That means, as a picture, nothing in this strip here where I just put this black zigzag line, don't think that is shaded. Nothing in that area is true. So the black dot is true for neither inequality. The orange dot is true for the blue line, the blue inequality. Now my question is, what about the purple? think about it for a second. It's on the green line. Is it true for any of them? The answer is no. It's not true because the inequality doesn't say equal to. It's just a less than sign, which means that everything up to the line but not including the line. So remember, this just represents pictorially what these two inequalities, if you graph them on the same line, had in common. All right. Now I'm going to give you another set and you're going to work on your own. What I would like you to do is graph these two inequalities. Make sure you shade. Make sure you keep in mind which one is a solid line, which one's a dotted line. And we'll come back together in a few minutes. All right, welcome back. Again, I'm going to do this line in blue and this line in green. So I'm going to go through this quickly with regard to the y-intercept and the slope. So the y-intercept is positive 1. The slope is negative 2 over 1. And it is a greater than or equal to. So is it a solid line or dotted line? Solid or dotted? So remember, if it's a greater than or equal to, less than or equal to, it's solid because it includes the line. So solid line. Okay, I'm going to test the origin again. Is 0 greater than 1? Because remember, if I put 0 in for x, that's going to cancel that out. Is 0 greater than 1? No, it is not. So I need to shade this side of the line. So hopefully you shaded that side. Now go into my green line. I'm going to go up 2. I put a line, and my slope is up 1 over 1. And I have not a solid line, but a dotted line. Because it's not equal to, therefore any point on that line is not a solution. It's not going to make it a true statement. So again, let's choose the origin. Is 0 greater than 2? 0 greater than 2? No, that's a false statement. So then the other side of the line must be true. So then I'm going to shade the other side of the line. Now here is the tricky part. The answer where both of them are true, if I asked you what that area was, that would be this area here, where both of them are shaded. So any point in that red area, but not on the line of the green, will be a true statement in both inequalities. So I'm going to go through this. Point 1, point 2, point 3, and point 4. Point 1 is only true for the blue line. Notice because it's shaded by the blue but not the green. Point 2 is shaded by the blue and the green, therefore it works for both of them. Point 3, I just realized you couldn't see point 4. Point 3 only works for the green line but not the blue. And then point 4 doesn't work for any of them. So that's what the picture is telling me right there. Anything in the point 4 area is not going to be true for either one. Anything in the point 1 area and that blue shaded will just be true for blue. Anything with 3 will just be true for green. And anything in red, where it's blue and green, that's where it's true for both of them. That's the actual solution, because you want to know where it's true for both of them. All right. Great job today. If you have time, go ahead quietly. You can take out your phone, check your text messages. Again, do not congregate by the door. Stay in your seat. And I will see you when I get back. I hope you have a great day.